Hi, everybody. This is Margie Meacham. I'm President and Chief Freedom Officer of LearningToGo.info, and I am the speaker for session 405, All Tips and No Hype, the Neuroscience of Instructional Design. In this presentation, I'm giving you an insider's tour of the brain as part of your pre-conference material. The information here is not going to be repeated in my session, but if you're new to some of the concepts of neuroscience or just want to refresh your understanding, it will certainly help you understand some of the terms that I'm going to be discussing when we get together in Denver. So what we're going to do in this little presentation is we're going to talk about the latest developments in neuroscience, at least some of them, that relate specifically to what we all do for a living, and that is to enhance learning and performance and develop talent. I'll also give you some additional resources so you can continue to expand your knowledge, and you can do that before the conference or, of course, anytime after the conference. So let's begin. First of all, a little bit of a brief history of learning and our understanding of how people learn. At the beginning, we were already teachers even before we as a species could speak or write, because we showed each other through demonstration how to do the things we had learned to do that kept us alive. We helped ourselves survive as a species by learning, and that has become one of our key strengths. The ancient Greeks understood that questions were the best way to help people learn, and here we see Socrates using the famous Socratic question method to get the learner to think through the answer rather than just give it to them. Then we come along, and I jump way ahead in history here to Sigmund Freud. He started studying the way the brain works from the emerging field of psychology. Now, psychology is great, and I don't mean to cast any dispersions on it. It has been our primary source for understanding how people learn for the past 100 years. But here's the challenge. Up until very recently, we couldn't really see what the brain was doing. We just had to develop theories. In fact, the only person who really took what would be considered a classic scientific approach was Pavlov. And you might have heard of Pavlov's dogs and this concept of conditioning. He tested how dogs reacted to stimuli that made them think they were going to get dinner, and they reacted by drooling and getting excited. And in this little cartoon, we're poking fun at that Freud thought he was controlling the dog, and the dog was actually controlling him. There's actually a little bit of truth to that, and anyone who's a pet owner knows that their pet has them very well trained. And then all of a sudden, everything changed. New technology came along, technology that allowed us to watch a brain while the person was alive. It's called a functional MRI, and there are other techniques as well now to look inside the brain and see what it's doing. And what we saw absolutely astounded us, and 10 years later, we're still trying to figure out what it all means. It opened up a whole new branch of science called neuroscience. So let's see how this new discovery has changed the way we think about how people learn. Just take a look at the questions here and maybe jot down your answers. I know you're all learning professionals, so I imagine that some of these statements you've heard before, and you probably have a pretty good feel of whether they are true or false. So just go ahead and test yourself. And let's see, and if you want, you can certainly pause this video, but I'm going to go ahead now and show you the answers. Now, you may be different, but I show this quiz every time I give a talk or a webinar, and so far nobody has gotten 100%. And when I first saw it, I guarantee you I did not. The reason that we're also surprised is that a lot of things we've been taking as fact have been proven to either be flat out false or at least completely unfounded by any kind of observable science. So I'm going to be very interested in meeting you in Denver and talking about this so we can compare what we're learning and talk about how we can help all of our peers start to understand what's going on in the brain. In this pre-conference session, I'm going to lay a little bit of foundation. So we're going to start with the tour of the brain in a physical sense. So the first thing we're going to talk about is the cortex. The cortex is the outer layer. It's what you normally think of as the brain. It's that wrinkly stuff that you see, and it's usually divided into 4 lobes or sections: the frontal lobe, the temporal lobe, the parietal lobe, and the occipital lobe. Occipital lobe, whoa. Okay, I'm recording this late at night. You know what? I'm not going back. That's how I said it. So bear with me, please. Now, in the frontal lobe, we've learned, or at least we're pretty sure, that part of the brain controls your eye and head movements, and it's also responsible for what we think of as consciousness, your behavior, your emotions to some extent, but we'll get to that. There's something else at play when you have an emotion: your speech, your cognition, problem solving, and what you're doing right now, watching this video, listening to me. That's all going on in the frontal lobe primarily. The temporal lobe has to do with hearing and, again, with speech and language. So one thing you start to notice right away is there's overlap and cross communication. It's convenient for us to talk about these as lobes, but if we opened up a skull, we would not see the image on the right with all those nice colors and those clear separations. We would see what you see on the left. We would see a very complex structure, and it has been the scientists who have determined these separations. So keep in mind that it's sort of a construct that makes it easier to talk about the brain. The brain is far more complex than what I'm going to show you here. In the parietal lobe, we have spatial awareness. This is where you know, for example, even if you close your eyes, you know where your hands are. It helps you with navigation, and our brains are not nearly as good at navigation as some of the other animals. It also is our sense of touch, which helps us explore our world. So you can see where there's kind of a connection with all of those types of functions. In the occipital lobe, hey, I said it right that time, visual recognition and vision are primary functions that we've identified. So how is it that the frontal lobe controls the eyes and the eye movement, but we process the vision way over there in the occipital lobe? Interesting, huh? In the cerebellum, which is on this picture you see on the left, that's actually at the bottom of the brain, the base of the brain. That's where you get your balance, your muscle coordination, your athletic ability or not, your reflexes, and it runs most of your involuntary motions. For example, we don't have to tell ourselves to breathe, although we can take that over if we want to take a deep breath or if we want to hold our breath. But notice again, that's a very interesting cross communication, because there's another part of our brain that has to do with touch and navigation and movement. So, you know, they're kind of crossing over each other. So what we've learned about the brain is really only scratching the surface, and very likely some of the things we think we've learned, we're going to find out are not really true as we continue to study it. But here's a few things I want to talk to you about. They're by no means all of them, but these are some of the big things that jump out at me when I look at the literature in terms of what I do for a living. And I'm like most of you, I'm a learning professional. I'm an instructional design consultant. So while I'm very interested in the science, I'm far more interested in how do I apply it. And that's what we're going to talk about when we get together in Denver. That's why I made my title, All Tips, No Hype, because I think there's an awful lot of exaggeration, oversimplification, and kind of gee whiz stuff coming out about the brain, but very few people really roll it up their sleeves and say, now here's how we're going to use this stuff. And here's what's going to change about the way we help people learn. So here's a few things that I'm going to lay as a foundation, so when you come and see me in Denver, we can have a more robust conversation about that application. So the first thing you have to understand about the brain is it's really a survival mechanism that evolved through evolution. And you see here that as our pre-existing cousins started to evolve and become more and more advanced, they gradually became Homo sapiens. Now, a really interesting thing at the end here is you'll see Homo sapien Neanderthal and Homo sapien sapien. Well, that last guy on the right, he looks like the modern man, right? And he is. And the Neanderthals, who are now extinct, take a close look at those two brains. The Neanderthal brain was actually larger, essentially the same as ours. I am not about to explain what that means. I just find it fascinating. But here's what all of these brains had in common that was very significant. We're not a particularly strong species. We're not particularly fast. We don't have a very good body for surviving out in the wild. But we have exceptional skills inside that remarkable brain of ours. And over time, in order to get more and more capability, it started folding over itself. And that's how we get all those wrinkles that you see on the brain. That's the cortex. And if we were to stretch it out, it would be a whole lot bigger and it wouldn't fit in our skulls. So that's why it's all folded up. Now, the next thing I want you to remember is that we really need to stop thinking about the brain the way I've been showing it to you, because it is completely connected, as you see here in the picture, to the entire body. There are nerves made up of neurons all through the body. And so I like to say the brain is distributed throughout the body. And that's probably an oversimplification. And some of you who are actual neuroscientists can help me with a better language later. So if something happens to your body, it happens to your brain, and vice versa. Those of us who've been classroom trainers understand that very well, because if your classroom is not comfortable, you are not going to get much learning done. Another concept, and this is really a central one, that totally surprised scientists was that the brain is not fixed. There was a time, and I was growing up in that time, and unless you're 15 years old or younger, you grew up in that time when everybody thought that once you reached adulthood, your brain stopped developing, you did not grow new brain cells, and your brain was fixed. And your intelligence, they believed, and certain other capabilities were fixed at birth. They were part of your genetic profile. We've now learned that that is not really true. There is a small percentage of your capabilities that's an inherited trait. All the rest is developed. And so what this means is it is never too late. If you've got a brain, it is rewiring itself constantly. The connections between the neurons are constantly changing. It's making room for new information. It's connecting new information to old information. It's questioning whether the old information is right anymore. It might throw out some of it. Right now, you can't help it any more than you could stop your heart from beating. Your brain is rewiring itself right now. And you're going to do a whole lot of that as you experience the flipped learning experiment that we're doing here, and also when we all get together in Denver. And it is actually possible to increase what we call classic intelligence, the way they measure it on tests, as opposed to some of these schemes and definitions of different types of intelligence. What do you think of that? Classic intelligence, it's basically around verbal ability and mathematical ability and maybe a little bit of logic, which is really just another form of math. So they have proven that people can increase their intelligence by maybe as much as 15, 20 points. You can always learn a new skill and you can always unlearn something. So it is never too late to change behavior, attitudes, or beliefs. And for the people, and I really don't get into this part too much because I'm focused on learning in the workplace and in an organization. So I don't work a lot with people who might have a disability or an injury, but the brain has remarkable recovery powers. And it is always possible to recover at least partially from an injury as long as the brain is still functioning, as a brain. So except for those severe coma or a brain dead situation. Now, while these neurons are reconnecting all the time, that means that memory at the beginning is very transitory. Now, you've experienced this if you've ever looked up a phone number and then immediately dialed it into your phone. You remember it long enough to do that. If someone asks you later, what number did you dial? You're probably going to have to pull it up on your phone because you only dialed it the one time and you didn't think you were going to need it, number one, which is a decision your brain makes, and you only put it in once. Repetition forces those same neurons to pass over that information from cell to cell again and again and again. And the more times you do it, it's just like a path being worn by the people walking to the beach. If they all walk the same way, over time, we get a nice wide path. Now, if for some reason the beach is closed, say, and it's months before anybody goes there again, we won't be able to find that path because it's all been grown over. The grass has overcome what used to be a path, and that happens with our memory. So we trainers and instructional designers, we know this instinctively, right? You're probably nodding your head saying, well, that makes sense. Of course, I know people have to repeat. What you may not be aware of is how much they have to repeat information before they can really own it and retrieve it a week, a month, a year after the training. At the same time that we're cementing neural pathways through repetition, the brain is also pruning. It's and a neuroscientist named Donald Weve, and you certainly can look up his work, has a famous saying, neurons that fire together wire together, and the ones that don't are broken up. If we don't use it, we lose it. Again, probably something that makes a lot of sense. Another thing our brain is really good at and really bad at is paying attention. This is my little dog, Dingo, and he shows so perfectly a brain, which is actually incredibly, very much like ours, paying attention. Well, it's kind of important if you are a fragile mammal without a lot of strengths out there trying to survive by your wits. And any movement, any sound could be a threat, a future mate, a friend, a foe, or dinner. So our brains are constantly scanning our environment. Our brains don't know that we're living in the 21st century, and most of us, thank goodness, are living pretty comfortably, and survival is not a day-to-day challenge. Our brain thinks it is, which explains a lot about our behavior, particularly in organizations, particularly in times of stress. But it also explains why it's very difficult for any of us to pay attention to anything for more than a few minutes. And in fact, studies show that even as hard as I've tried, and I hope I'm making this interesting, as hard as I've tried, you have already wandered into other thoughts many, many times during this. You wander and then you come back. You look over here and then you come back. Even I have been doing it while I've been talking to you. You might notice on the flipped side, because we've got a Twitter feed from all of the members, that those of us in the Phoenix area have been commenting on these tremendous thunderstorms we're having. Well, I have a beautiful view of that out my window in my home office here. And, I've been kind of watching it. Every once in a while, I look up and I see a glorious flash of lightning. So you can't help it as hard as you try to pay attention. In fact, sometimes forcing yourself to pay attention can actually make it even harder for you to really absorb. So it's okay that our brains do that. It's great that they do that. We just need to be aware of it as trainers. That's why we can get their attention with movement or sound. Our brain is very good at noticing similarities or differences, because those patterns tell us whether we're looking at a positive situation or a potentially dangerous one. We're also really good, and any of you who have a pet know, your pet knows if there's a treat in your pocket, right? We also pay attention to our own emotions, because those also are significant for survival. And of course, food, and the number one thing that keeps the species going, sex. And all of those things can be used by an instructional designer to get attention. And if you think sex isn't used, let me just tell you this. Studies show that when you use a human spokesperson in your training, everyone will pay more attention to the woman. Men will pay attention to an attractive woman for obvious reasons. Women pay attention to that attractive woman too, because she's seen as maybe, and this is only a theory, this is one of those things we can't prove yet, maybe a female voice is more nurturing and less threatening. So who knows? That's something to explore another day. Another thing we all know, and that's why we're gathering in this flipped learning format, and that's why we're going to all be together in Denver, is the social brain. And I know you've been hearing a lot about this. Well, the reason that Twitter went crazy, that everybody loves it, the reason that we love Facebook and a lot of more recent parts of social media now, is because we are hardwired to need each other and to connect with each other. And so as the digital age made it less and less likely that you were connecting physically with people, it's quite possible you can go through your whole day like I do. I get up in the morning, I say hi to my family, go to my home office. I might not come out until 7, 8 at night. But during that time, I've had wonderful interactions. I might be IMing somebody. I might call a client on a phone. I might do a webinar. I might get on a video chat or Skype. So those kind of things, they keep us going. We get a rush when we're with our fellow humans. We're more attentive, we're healthier, and that chemical rush, it's similar to a chemical high. We need each other. The reason we're programmed that way is because when we stick together, we tend to survive. And when we learn together, we learn more. This next thing that we've learned about the brain is reflection. Every brain, because its experience has been unique, constructs its own version of reality. And that's why whatever training you build or deliver, it's a little bit different for every single participant every single time they go through it. What reflection does is it lets us more finely hone that construction that we're making. And you probably know that when you went to school, if you were someone like me, I obsessively took notes. I studied the notes. I rewrote the notes. And by the time the test came along, I was pretty sound. I didn't have to do a lot of studying the night before. I had mastered the content. When we reflect, We're going back over those pathways, but we're also reaching out to other neural pathways. How is this connected? How is this different? How can I use this? What does this mean to me personally and to my values? Many, many times I fear we don't allow time for reflection in our busy world, and particularly with a lot of demands in the workplace. So, hey, you finished training, get on out there and use it. We need you back online, right? Please, please think about adding reflection in your instructional designs. Another wonderful skill that our brain has is it actually predicts the future, and it does it pretty well. And if you don't think that's true, here's what we mean by that. Based on past experience, we have an expectation about what's going to happen next. So by now, you're pretty sure I'm not going to start singing or put on a video of me dancing or show you funny cat videos. I'm going to be talking about the brain. You have made that conclusion based on just a few minutes with me. But here's where sometimes the brain gets tripped up because it is so good at recognizing patterns and extrapolating what's going to happen next. It can get really confused when the pattern doesn't fit. For example, when you're undergoing a lot of change and now all of a sudden the workplace is not the way you expect it to be, or in the case of an optical illusion. Now, I've already given you a tip, so already, because you've heard that term before, you know the answer to this question, or at least you know what isn't the answer. If you look at this checkerboard and you look at that picture, tell me which one, and just pretend I'm sitting there with you, which square is darker, A or B? Even though you know it's an optical illusion, I challenge you to see B as the darker color, and yet, in fact, it is. So why can't our brains see that even when we're told that B is darker than A? Because the rest of the board fits a checkerboard pattern we have seen many times. It's very familiar to us. And the shadow cast by the cylinder adds to the illusion. We know what happens when things are in shadow. And so we start to form an expectation about A and B. I want to say the second, but it's a millisecond. The instant the brain, the eye picks that up, it relays that information to the brain, and the brain draws a conclusion, says, okay, what we've got here is classic checkerboard, and the colors are going to alternate. And even though they in fact do not perfectly alternate, which is why A is lighter than B, we can't see it. And sometimes that inability to see that we are in a scenario that is different from our prior history trips us up. So let's get some social learning going. I'm really excited about this. I hope you're going to join me on the Flip Learning site. Also, please join me on Twitter, and don't forget our hashtag OLCONF for online conference. And I really hope you join me at my session. We're going to have a lot of fun, and we're going to have a great exchange. I promise no overhyped claims. We're just going to talk about practical ways that we can use brain science, things you can use immediately. My session is 4:05. It's called All Tips, No Hypes. I'm Margie Meacham. It's Thursday, October 18th, bright and early at 8:15 to 9:15 a.m. I've added some resources here at the end. I will, in addition to this recorded session, I'll upload the slides so that you don't have to copy down these long links. You can click on them. And I have 2 pages of resources. So I hope you enjoy those. I certainly don't expect you to access them all. Some of them are books, some are articles, some are interesting websites, but certainly pick and choose a few. And let's have fun. And let's see each other in Denver. Thanks so much for taking the time to go through this. and I'm really hoping that we have a chance to talk live. Bye.